Okay, so the second video, we're going to do two that are going to be around the x-axis. I'm going to walk you through this one. I'm going to ask you to pause it and try the next one, and then come back and watch my explanation of the next one. So it says, set up and evaluate the integral that gives the volume of the solid formed by revolving the region about the x-axis. For this one, it's 1. For number 1, it is the function y equals the square root of 9 minus x squared. Sometimes you won't be given a picture. I'm giving you a picture right now with the curve. Because we know that the square root of 9 minus x squared does go into the negative. So if that's all it was, you would have to draw the whole thing. But I'm giving you this picture so we know where to start. Otherwise, you may be told that it's also bound by the y-axis or line x equals 0. So you kind of know where to stop your shading if you are having to draw it, which you will. So here's our rectangle, and we're going to draw it perpendicular to my x-axis. Reason is because we're revolving around the x-axis. Okay? So it'll be in the form of dx. So we're going to use what we learned earlier is volume equals pi r squared times height for a right circular solid, so a cylinder. So we're going to set that up in the integral to find our volume. I'm just going to throw my pi out in front every single time because it's a constant. So like, why put it in there if we have to take it back out? Your boundaries will be your x min to your x max when you're in the direction of x. Otherwise, it'll be y min to y max. So in here will be our radius squared and then our dx. So when you look at this, your radius is the height of your rectangle, wherever you're drawing it. What gives us that y value, that height? Our function. So that's going to be the radius, no matter where you draw your triangle and no matter how high the triangle is or how close to the x-axis it is, all of these have a height of square root of 9 minus x squared. Okay, every single rectangle. So when you're looking at these discs, the radius will be equal to the function value, and in this case it is the square root of 9 minus x squared. And yes, we're going to square this. So our boundaries are 0 to 3. Okay? So before we go ahead and integrate this, I do want to simplify the square root of 9 minus x squared squared, which is just 9 minus x squared dx. And sometimes you may have to use u sub. Sometimes you may have a trig function in there, or maybe an exponential. You know how to do all those, so don't forget that. This one is simple. It's just our power up rule, so we will go ahead and do that. So it'll become 9x divided by 1 minus x cubed divided by 3. And we're going to evaluate that from 0 to 3. And once we do that, will give us the volume of the solid. If we were to take this arc and rotate it around our x-axis. Okay, so at this point, you can plug it in. So we get 27 minus 9, which leaves us with 18 pi. Okay, so kind of picture, if we look at this one in black, if this were to come forward, that were to come forward. Again, I'm not really great at drawing 3D images, but what we get here is our solid. That is rotated. Ugh, that doesn't look very nice, but hopefully you can see that. If you're having trouble seeing that 3D image, again, you can go, obviously in the book, open your book, go look at some of the pictures. Even going back to the first picture I showed you in video 1. But you just want to picture all these discs being stacked together, and if you're finding the volume of all of them and adding them together, it'll give us the total volume of this figure. So question 2 is, I want you to try to do this one. Y equals 4 minus x squared This is a quadratic. So for this one, I would have to tell you something or give you a picture. I am going to give you a picture. It is a parabola, shifted up 4, reflected over. So this is the shape that we're looking at. And we are going to rotate this around our x-axis. So if you're asking yourself, where should you draw your triangle? You draw your triangle to get your disc perpendicular to your x-axis. Okay? So I want you to pause the video right now, and I want you to try it. Okay? Look at the one from up above. Try setting up your integral, and then try doing the integration process and then the substitution in. And remember, all that is, it's just your pi r squared times your height. That's your dx, okay? Because obviously the change in x will be our width of all of the discs that are being stacked up, okay? So go ahead and pause it and then come back. All right, welcome back. It's still not done, but I did want to have this written out for you. So I have the volume as I just put the pi out in front, my radius of every single cylinder that will be there. We'll have a value of 4 minus x squared, depending on how far away we are from that y-axis. Obviously, the closer we are, the larger it is. The farther away, the closer we get to 2, the smaller the radius will be. Before I want to integrate, I'm going to FOIL that. I don't have to worry about use substitution and all that stuff. Since we have a polynomial, this will be pretty easy. So I already FOILed it. Go ahead and do your power up rule. And evaluate at 2. And what you should get is 256/15 pi. All right, I hope that went well, and I hope you got that one. The next video for today is going to be regions being rotated around the y-axis, okay? So everything will be in the y direction. I'll walk through one with you, and then I'll have you try one, and then you'll be off to being able to do your homework.